So if we had the simple equation x plus 4 equals 0, how would we solve it? We want to get the x by itself, so we need to undo adding 4. We undo adding 4 with subtracting 4. Whatever we do on one side, we do on the other. It leaves us with just x on the left, and then 0 minus 4 is negative 4 on the right. If we wanted to express our answer as a set, it would be the set containing our answer, one number, negative 4. Solving an inequality is pretty much exactly the same as solving an equation. And I say pretty much because there is one important difference, but that difference doesn't come into play here. So let's say instead of equals, it was less than or equal to. X plus 4 is less than or equal to 0. You do the same thing, and you get the answer x is less than or equal to negative 4. Not bad. If you can solve equations right off the bat, you can solve 90% of inequalities. And I pulled that number out of thin air. No one ever has real percentages when they say that. What someone means when they say you can solve 98% of problems using that, they mean most. Great many most. So what's the special rule? What are the ones that we can't solve like that? The rule comes into effect when you multiply by or divide by a negative. The word by is very important here. It doesn't mean any multiplication or division involving a negative. It is only when you have something and you're taking what is there and multiplying it by a negative number, or you are taking what is already there and dividing that by a negative number. That first number can be positive or negative, doesn't matter. The rule only kicks in if you are multiplying by a negative or dividing by a negative. And here's what happens. If you have that, you switch it to that. If you have that, you switch it to that. It is laughably easy if you can already solve equations. So if at this point you're not having any struggles with solving equations, if you are consistently getting the right answers, then all you're going to have to watch out for here is multiplying by a negative, dividing by a negative. And it's not going to be in every problem, but we will do a lot of problems where it does happen because those are the more interesting ones. But every problem is not going to have a flip. This one will. Let's say we have negative 6x plus 4 is less than 34. Well, let's pretend it was equals 34, and let's not do anything differently until we get to a step where we might multiply or divide by a negative number. Okay, so we want to get the x by itself, which means we want to get the 6x by itself, the negative 6x. Well, I can go ahead and subtract 4 from both sides because I want to keep it balanced. That leaves me with negative 6x on the left. Subtracting 4, that's not multiplying or dividing by a negative. So keep the sign like it is. 34 minus 4 is 30. I want to get the x by itself. I'm going to divide by -6. Warning, warning, danger, Will Robinson. I was going to say that's an old reference, but by golly, there is a remake, so it could be a more recent reference if you're danger. We are left with x on the left, but since we are dividing by a -6, the less than becomes greater than. Positive 30 divided by -6. Positive divided by negative is negative. 30 divided by 6 is 5. So the solution to this inequality is x greater than -5. On a number line, that means we would be at -5. There's no or equal to, so it's a parenthesis. And we want a graph greater than. So it's an open parenthesis with the shading to the right. Our answer in interval notation, we can see from that, would be a parenthesis at -5, and it goes to infinity. Infinity always takes a parenthesis. So the answer in interval notation, parenthesis, -5, comma, infinity, parenthesis. Let's do another. -5t minus 6 is greater than or equal to 24. Let's not do anything differently than normal solving of a linear equation until we run into a step, which may or may not happen, where we multiply by a negative or divide by a negative. To get the t by itself, we've got to get the -5t by itself. We've got to add 6 to both sides. Leaves us with -5t on the left. Leaves us with positive 30 on the right. Adding 6 is not multiplying or dividing by a negative. The inequality symbol does not change. Here, we are going to divide both sides by -5. Danger, Will Robinson. Switch the inequality sign. Positive 30 divided by -5 is -6. So t is less than or equal to -6 on a number line. We have -6. The or equal to means a square bracket. And since we want less than or equal to -6, it's going to point off to the left. And there's all of our shading. From here, we can see that our interval notation, we're going to start with -infinity. We're going to end with a square bracket at -6. Comma separates. So our interval notation for t less than or equal to -6 is going to be parenthesis, -infinity, comma, -6 square bracket. Okay, you're doing great so far. Let's complicate the inequality a bit. Let's take a look at -6 times the quantity x minus 3 is greater than or equal to 2 minus 2 times the quantity, x minus 8. So again, we are going to treat it like it said equals, unless we come to a step where we are multiplying by a negative or dividing by a negative, in which case the inequality sign flips. So with parentheses, what do we do first? Well, in an equation, we distribute to clear the parentheses. And that is what we do here. We're going to distribute the negative 6. Over here, we'll distribute the negative 2. Negative 6 times x is negative 6x. Negative 6 times negative 3, positive 18. On the other side, distributing the negative 2, bringing down the positive 2, and this will be greater than or equal to. There's no risk of us doing anything here. You might be saying, wait a minute, you're dividing this side by a negative, or sorry, multiplying this side by negative, and you're multiplying this side by a negative. Isn't that the special rule? No. These negatives already exist here. In the other problems, it's the steps of undoing everything. If we're multiplying by a negative in the problem, we will divide to get rid of it. But here, we're not getting rid of the negative 6. We're getting rid of the parentheses. And we're not actually multiplying the same thing on both sides. So this isn't what we mean by multiplying both sides by a negative number. Bring down our 2. Negative 2 times x is negative 2x. Negative 2 times negative 8 is positive 16. Yes, I will show an example of what we do mean by multiplying by a negative number after this one, because we've been doing dividing. So I will show one that clears up what multiplying both sides by a negative would look like. In the meantime, let's finish this one. Simplify by combining like terms on both sides. Nothing to combine on the left. On the right, positive 2 plus 16 is positive 18 minus 2x. I'm going to go ahead and add the 2x to both sides. Negative 6x plus 2x is negative 4x plus 18. If I subtract 18 from both sides, I get negative 4x is greater than or equal to 0. And let me write this over here. From negative 4x greater than or equal to 0, if I divide both sides by negative 4, I get x is less than or equal to 0. Got to flip that sign because we divided both sides by negative 4 in the process of solving. On a number line, if this is 0, less than or equal to 0 would look like that with a square bracket, which means our answer would be negative infinity to 0 with a square bracket on the 0. So just real quick to knock out that one I promised you before we do another one just like this. Something where we'll end up multiplying both sides by a negative number could look like this. T over negative 3 is less than 1. Here we would need to undo dividing by -3. We would do that by multiplying by -3. And here we're multiplying both sides by -3 to undo division. And that switches the sign. 1 times -3 is -3. Hopefully by now we're getting used to putting our answers in interval notation and getting that interval notation from graphing. Let's do another one with all the parentheses. 5 times 3x plus 1 is less than 4 times 5x minus 5. Distribute. 15x plus 5 is less than 20x minus 20. Going to subtract 20x from both sides. That leaves me with -5x plus 5 is less than -20. I'm going to subtract 5 from both sides. -5x is less than -25. And from there, which I'll move up here, I'm going to divide both sides by -5. Leaves me with x is greater than, because that flips the sign. Negative divided by negative is positive. 25 divided by 5 is 5. 5 to infinity inside parentheses. Okay, let's throw in some work with fractions here. X plus 1 over 3 minus 2x minus 4 over 6 is less than or equal to -x over 2. Now, here, we can go ahead and multiply both sides by the least common denominator. And in this case, that's going to be 6. So if we look at our multiple list for 2, 3, and 6, six is the first number that shows up in all 3 of the lists. That means that 6 is the least common denominator of 2, 3, and 6 fractions with those numbers in the bottom. Why am I doing this? I'm doing this because it's going to get rid of the fractions. So notice, multiplying both sides means that the 6 gets distributed to both of these terms. So it's like having a 6 times the x plus 1, and all of that's over 3. It's like having a 6 times the 2x minus 4. All of that's over 6. And here, it's like having a negative 6x over 2 instead of just an x over 2. The 6 gets multiplied by that fraction. How is this helpful? Like I said, it's going to get rid of the fractions for us because 6 over 3, that's just 2. And then 6 over 6, that cancels. So that's minus the entire 2x minus 4. Very important to keep that in parentheses because it is subtracting that entire thing, which means in the next step, we're going to have to be sure to distribute that negative. Less than or equal to negative 6 over 2. That's negative 3x. And look at that. The fractions are gone. If I keep simplifying, I'll get rid of the parentheses next. 2x plus 2. Distribute to get that negative through there. Negative 2x plus 4. The opposite of the negative is positive. Less than or equal to negative 3x. If I combine like terms on the left, 2x minus 2x, those cancel each other out. 2 plus 4 is 6. Less than or equal to negative 3x. When we finish this up, 6 less than or equal to negative 3x, we see we're going to have to divide both sides by negative 3, which is going to flip the sign from a less than or equal to a greater than or equal to. 6 divided by negative 3 is negative 2. We're just left with the x there. Be super careful. This one ended up with our x on the right. This would be the same as x is less than or equal to negative 2. So right now, don't ask, why did it flip back? It didn't flip back. Here, we switched it, but the left side stayed the left side and the right side stayed the right side. Here, we're switching the whole thing. The left side comes from the right side. The right side comes from the left side. And then the little point stays with the x. The little point stays with the x. Pac-Man's mouth opens towards the negative 2. So on a number line, this would actually be to the left. Negative infinity to negative 2 with a square bracket. Let's go ahead and do another like this one. M minus 4 over 2 minus 3m plus 4 over 10 is greater than negative 3m over 5. The LCD, the least common multiple of 2, 5, and 10, that's going to be 10. I'm going to go ahead and multiply both sides by 10 so that I can get rid of the fraction. So this would be 10 times m minus 4 all over 2 minus 10 times 3m plus 4 over 10 is greater than, this is going to be negative 3 times 10, negative 30m over 5. The 10s cancel there. Here, 10 over 2 is 5 of these m minus 4s. And we're subtracting, in parentheses, the entire 3m plus 4. And then negative 30 divided by 5 is negative 6m. Distribute 5m minus 20 minus 3m minus 4 greater than negative 6m. I'm going to go ahead and erase the top of this problem to give myself more room to work for now. I'm going to recopy this line exactly with no changes. 5m minus 20 minus 3m minus 4. This is, again, just so I have the room. You don't need to write this a second time. You can obviously just keep going. It's minus 3m. 5m minus 3m would be 2m. Negative 20 minus 4 would be negative 24. Less than minus 6m. I'm going to do this two ways. So there goes the rest of the middle. Because I'm going to do this two different ways to show you that there is a way where we don't flip here. So two different ways. You don't have to do both, but I'm going to show we get the same answer either way. So I'm rewriting this line two ways. First, I'm going to do it like we did the last problem. Since I can get this all done in one step by subtracting the m's to the right, I'll go ahead and do that. If I subtract 2m from both sides, negative 24 would be greater than negative 8m. And then I would divide both sides by negative 8. Negative divided by negative is positive 3. But since I did divide both sides by a negative, the inequality sign gets flipped from a greater than to a less than. We get 3 is less than m. To help me graph it properly, I'll switch the whole thing around so that the m goes over here and the 3 goes over there. And then the big side stays with the m and the little point stays with the 3. So this would be m is greater than 3. No or equal to 3 to infinity would be the answer. What if I always, no matter what, wanted to do every problem by taking the variables to the left and the constants to the right? In other words, what if I did do plus 6m as the step here? That'd be okay. There's nothing wrong with that. Be careful though, because now everything is on the left. 8m minus 24 is greater than what? 6m minus, or negative 6m plus 6m, those cancel away completely. 0m on the right. Leaving the m's on the left, I would then go ahead and add 24 to both sides. And then look at that. 8m is greater than 24. No multiplying or dividing by a negative going on here. Just dividing by 8. M is greater than negative 3. Will you look at that? Same answer. So same graph, same interval notation. So either way, we get M is greater than 3 here. Suppose you were in a different class, not this one. Our grade is a little more complicated to figure out, but let's say you were in a class that has 5 test grades, 1 homework grade, worth as much as a test, and 1 final exam worth as much as 2 tests. The 5 test grades (96, 84, 80, 98, and 88. The homework, you got 100% on that. And all that's left is the final exam. What you want to know is, what do I need to get on the final for an A? And by the way, an A means at least 90%. There we go. We can see all that now. We can set up and solve an inequality to get this information. So that's one of the uses for solving an inequality. At least, remember, we talked about what that would mean. at least 90 means that the grade has to be greater than or equal to 90. At least means we do include the 90. So the grade would be greater than or equal to 90. We would need to come up with some sort of formula for the grade at that point. So let's see what it says. There are 5 test grades. The homework is worth as much as a test. That's a 6th test. And then the final exam, that's worth as much as 2 tests. 7, 8. Well, if you're getting an average of 8 things all counting equal, the final exam would be 2 tests, the grade and then the grade again. What do we call x plus x? X plus x, that's 2x. And then these 6 things added together. I think this is enough information to come up with something here. If we add up the 5 test grades plus the 6th test grade, which would be the homework score of 100, plus x plus 2x, those are the 7 things. Well, x plus x, that'd be the 8 things. 1, 2, 3, 4, 5, 6, 7, 8. An average of 8 things. That would be the grade, and the grade would have to be greater than or equal to 90. Well, even before we add all this stuff, well, let's add it up. Let's get the calculator. $96 plus 84 plus 80 plus 98 plus 88 plus 100 equals, this would be 546 plus 2x over 8 needs to be greater than or equal to 90. Let's say we wanted to know what would be a B. Well, a B would be between 80 and 90, not including 90. That would represent a B. But we're looking for an A. We need the grade greater than or equal to 90, at least 90. Multiply both sides by 8, 546 plus 2x would be greater than or equal to 720. 720 minus 546 would be 174. So 2x greater than or equal to 174. Divide both sides by 2. X, the grade on the final, would have to be greater than or equal to 174 divided by 2, 87. So you would need a grade greater than or equal to 87 on the final in this situation to get an A in that class. Not this class. Okay, so I'm not drawing the MasterCard logo. I am drawing two sets, a set A and a set B. And notice they have an overlap here. By the way, whenever we draw circles, and look how they overlap to represent sets, this is called a Venn diagram. So we have this Venn diagram here of sets A and B. And this part here, where A and B overlap, this is called the intersection of A and B. The symbol for the intersection is an upside down capital U. When we see the intersection of A and B, what this means is, where do the two sets overlap? What are the elements in common? So let's say A is the set 1, 2, 3. B is the set 1, 3, 5. What is the intersection of these two sets? In other words, what is the set A intersection B? What elements are in both? 1 is in both, and 3 is in both. So the intersection of sets A and B would be the set 1, 3. Because this set contains every element that's common to both A and B. Intersection is one type of thing. I don't want to say this other thing is the opposite, because it's not exactly the opposite. If it was the opposite, it wouldn't include the intersection. Next, we're going to look at the union. And the union is an actual capital U looking thing. So it is the upside down version of the intersection symbol. Union, capital U, just like the U symbol. Intersection's the other one, that's the upside down U. Union just means join together. So the union of A and B would be all of A mixed with all of B. So here, if A is 1, 2, 3, and B is 1, 3, 5, A union B is going to be the set 1, 2, 3, 5. Every element from A and every element from B makes it in to the final union set. So let's take a look at some larger sets. These were just 3 elements apiece. let's say we have set A 1, 3, 5, 7, 9, 11, and set B 1, 2, 5, 7, 12. We're going to look for A intersection B, and we're going to look for A union B. The intersection, where they intersect, where they overlap, elements common to both sets. 1 is in both, not 2, not 3. 5 is in both. 7 is in both, not 9, not 11, not 12. So that's it. The intersection is the set 1, 5, 7. The union. Union is everything. If it's in A, it's in there. If it's in B, it's in there. So 1, 2, 3, 5, 7, 9, 11, 12. Every element from A or B makes it in. In fact, what did I say here? Every element from A or B makes it in. What word would we use for making it into here? It makes it in if it is in A and B. So an intersection is an and statement and vice versa. When we have an and statement, that means the overlap. When we have an or statement, that is the union. That's both brought in. Still have another 20 minutes or so. If you need a break, take a break. We're going to expand this idea. And instead of sets that are listed out, we're going to have set builder notation. So we're going to let C be the set of all X such that X is less than 4. We're going to have D be the set of all X such that X is less than or equal to -2. We are going to look for both C intersection D, and we are going to look for C union D, both of them. Well, let's go ahead and look at the graph. Put that in a little bit better spot. I'll just put it here for now. Deal with these when we get to it. Up top, I'm going to graph C, and below, I'm going to graph D. For that, we're going to need -2, and we're going to need +4. C is X less than 4. So a less than would look like that with a parenthesis, and we're shading the things less than 4. Less than or equal to -2 would be a square bracket, but we're still going to the left because we're shading the things less than -2. When X is on the left, it actually shows us, it points which direction to shade to. So which of these is going to be easiest? Well, they're both pretty easy. The intersection is the overlap. Where do they overlap? I'm going to do this one in green. They overlap right here. From -2 to infinity. So x, let's keep it an interval notation. -infinity to -2. That's going to be C intersection D. Or x less than or equal to -2. Or the set of all x such that x is less than or equal to -2. Or in this case, because we have a special name for this already, C intersection D could actually just be considered D. C union D, that would be both together. I'm going to circle this in red. Both together, that's all of it. And this right here, D, that's already a part of C. So C itself, x less than 4, or -infinity to 4, but not including the 4, would be equal to C union D here. Let's do another. If you've got it already, that's great. These next examples, make sure you still have it. If you don't have it yet, or if you're a little shaky, these next examples are really going to clear things up, I think. We have set A. Set A is going to be the set of all x such that x is greater than or equal to 3. We have set B. Set B is going to be the set of all x such that x is greater than -1. On a number line, we would need -1, we would need 3. I'm going to go ahead and I'm going to graph A. A is x is greater than or equal to 3. I'm going to use red for B, greater than -1, parenthesis there. The overlap is the intersection. Where does it overlap? Right here, from 3, including 3, to infinity. The intersection is all of it. This piece is included here, so all of it is just the same as the red one. A union B is just going to be from -1 to infinity. The intersection is the overlap, where it overlaps. The union is everything from both jammed together. New sets. A is going to be the set of all x such that x is greater than 0. B is going to be the set of all x such that x is less than or equal to -3. So what do I need on my number line to graph? I'm going to need 0, and I'm going to need -3. I'm going to go ahead and graph A. A is greater than or equal, or sorry, just greater than 0, not or equal to. So parenthesis, not a square bracket. B, that's going to be less than or equal to -3. Less than or equal to. Notice I didn't go below because there's not going to be an overlap here. No overlap means that there is no intersection. The intersection A union B is the empty set. A intersection B is the empty set. What about A union B? Well, we have this piece. We have the -infinity to -3 piece. But we also have this piece. And what we're going to do, I'm going to go ahead and write it down here so I have enough room. A union B is we're going to take the first piece and we're going to take the second piece and we're going to join them with the union sign. And this is another way of saying x is less than or equal to -3, or x is greater than 0. Because a union is an or statement. It makes it in if it's in this one or this one. They both come in. For an and statement, it would only be if it's in this one and this one. The two new hottest clubs are Club Union and Club Intersection. Now, the thing that makes these clubs fancy is that there's not just one list at the door, there are 2 lists at the door. And each club has its own rules. To get into Club Union, you must be on list 1 or list 2. If you're on list 1 or list 2, you get in at Club Union. Club Intersection is a lot more restrictive, okay? It doesn't let as many people in as Club Union. Club Intersection, you get in if you are on list 1 and list 2. So 2 lists at the door. Club Union, to get through the door, you just need to be on one list or the other. But to get into Club Intersection, you need to be on both lists. You need to be on list 1 and list 2. That's what Union and Intersection are. They're just like these exclusive clubs, and they have the exact same rules. For a union, you take them in if they're in one or the other. For the intersection, they have to be in both, first and second. Okay, we have time for some more examples. Let's take a look at the resulting set of negative infinity to 4, parentheses on both, intersection, square bracket 1 to infinity. So what I would do, just like before, we're going to go ahead and look at both of these. The interval from negative infinity to 4, we're going to need 4, 4. And we're going to need 1 for the other one. There is negative infinity to 4. And here is 1 to infinity. The intersection means the overlap. It has to be on both graphs to make it in club intersection, to get in this final answer. So where is the overlap? It overlaps here, with a square bracket on the left and a parenthesis on the right between 1 and 4. What about the union? Well, if we look at the same two graphs, and this time we want the union, then to make it into the final graph, it either has to be on one or the other. And between one and the other here, everything is covered. The answer here, all real numbers. Negative infinity to positive infinity. Let's do a couple more. Marker cap down, marker cap down.